While people are sitting down, a very quick announcement. Usually we leave announcements for the end, but this is one I want to make before I forget. Those of you with a physics background, and I'm talking, serious physics background, so a major in physics. A major in physics is great, a PhD is better. Who have any interest in quantum computing and want to do cool things with it, come and talk to me. And if you can't come and talk to me, contact me by message on the Meetup site or however else it is that people contact me, I don't know. The other thing is, anybody here speak Russian? Apart from the ones I already know, there is a heck of a lot of data science material in the Russian language, which is unfortunately not accessible to most of you, sorry. But for those of us who can read Russian and watch Russian videos, we've got a little group forming to look at data science by Yandex company and Russian Kaggle champions and so forth. So anybody interested in that, get in touch with me. Okay, over to our next speaker. And our next speaker is a very interesting speaker indeed, as indeed was our last one. And I could read you his blurb here on the Meetup page, and I will. But I should preface it by saying that most of this blurb, I got over a beer and a chat with him yesterday. But you see, the thing is, I hadn't read it. Like for some speakers, I just don't read the blurb. But I just started talking to him, and he goes, yeah, I'm doing some data science. So that's cool, of course you are. But I've got a physics background. Well, I have a lot of respect for people with physics backgrounds, as I've probably indicated. And he said, yeah, and he said, but I never finished a PhD. I started a PhD and didn't finish. I said, oh, really? Did you become a data scientist? No, I went off and worked in defense. I said, what? Really? Oh, and is that where you are now? No, I'm running a startup now, which I'm sure you'll tell us about. And I said, okay, so you went to your startup from defense? No, that was from my think tank job. Think tank job? Yeah, I was doing economic policy. Oh, so you went from like physics to doing like a PhD to like being too damn entrepreneurial to finish your PhD, to go into defense technology, to go into a think tank, to go into data science. Yeah, but I actually ran a cafe along the way as well. Yeah, well, anyway, that's. I'm going to read you the formal one, but I think that this is how I experienced it, okay? And that's not the end of it. That's not the end of it, because he told me some other stuff too. And then he walked up to me today and said, that's not to tell people. That's like, that's confidential. He's a man of mystery as well. I figured I can't tell you what it is, but I can tell you that there is something. He's a man of mystery. So anyway, about the speaker. AIDAN Morrison is the co-founder of TrendLock. Company's called TrendLock. I'm sure we're about to hear a lot about it. A data science and analytics automation company based in Sydney. Formerly a student of particle physics, he first encountered working with very large data sets on the Atlas experiment at CERN. Okay, I didn't know that. Since then, he has worked in economic policy analysis, I knew that, and also been involved in opening a cafe bar restaurant. From now on, people, anyone who wants to present to Data Science Sydney, good grammar, always. And Fabian, did you check this? And cafe bar restaurant called Backcountry in Radwick. You're in the eastern suburbs, that's right, neighbour. He enjoys turning analytic methods to many and various data-related problems, including defense policy and migration. AIDAN blogs at quixotic.com. Over to AIDAN.
All right, well, thank you so much, Eugene, for that extremely kind and flattering introduction. It's true that I've certainly had a few different roles in the last few years. Can everyone hear me if I move away from the podium? Is that still working all right? I think it is. That's good. So, yes, it's true. I do a bit of data science at the moment. So my main project is TrendLock. And we focus on trying to do data science on on-demand consulting contracting basis, trying to make it available for smaller companies. And we're also developing an amazing product to do a next level generation of the sort of stuff I'm about to show you today. I also want to introduce Ross Island, who's the other half of TrendLock over there. And he's another interesting guy that's come from different backgrounds and has amazing intellect and passion for ideas and discovering and challenging things. But Ross's secret talent, which I love him for, is that he's just an absolutely amazing, gifted programmer in R. He's one of these people who you kind of hesitate to ask for help with because you know it's the only way that you can get your code to run beautifully in about 2 or 3 seconds, but also you know that 2 or 3 minutes later he's going to turn around and say, oh here, that thing you're working on, I've just done it in about 3 lines, and your last few hours of work is kind of completely rendered obsolete, and you've got to ask for another push and sort of pull to start working again. So that's Ross. You'll hear about him some more. Anytime I say that I've done something, actually what I mean is we've done something, and anytime I say that we've done something, actually what I mean is probably that Ross has done most of the hard coding behind it. So that's sort of where we're at. And yes, I did open a bar restaurant in one of my entrepreneurial ventures. I sort of fell into hospitality while I was trying to sort of bootstrap that venture and loved it, and sort of opened one with a few friends, which is great. So it's still running up in Randwick now and is providing us with a great data set for today's presentation, which is really good. So I have an apology to make, actually. I want to start with to everyone that went to Eugene's brilliant presentation a couple of weeks ago in the management and strategy stream, because Eugene had what I think is actually a very good and reasonable definition of data science. And that is that data science should be used to inform decision making. Do I misquote you terribly badly there, Eugene? I think that was the essence of what the qualifying criteria was. And under that criterion, what I'm going to present today is mostly not data science, because what we're going to do is discuss fun things like, whether cappuccinos are in terminal decline and whether vegetarians actually drink more or less than other people that drink meat. So all this sort of stuff is absolutely not data science by Eugene's definition. It is just data play. And I want to make a case for data play having a role in the data science community because, as everyone said, data science has sort of suffered a tremendous amount of hype. I think we're sort of something of a sort of nascent adolescent phase, if you will. And really, really advanced stuff like machine learning and deep learning and artificial intelligence has sort of got this esteemed status. I heard someone else say this, I don't claim to quote myself, it's become a little bit like teenage sex, where everyone thinks that everyone else is doing it and everyone wants to be doing it and everyone says they're doing it, but actually not that many people are really, really doing it. And those people that are doing it are actually so uncoordinated and clumsy that they're not having any fun at all. So I think it's really important for the maturity of the data science space that we do allow data to be a little bit of fun, and we just kind of get our hands dirty and start doing things with it. So that's a bit of why I've chosen this thing. Otherwise, we just wind up sort of looking at what I call kind of data porn, which is stuff that's totally useless and tells you absolutely nothing that will ever be of any interest to you, and you congratulate a machine for telling it to you. So this sort of stuff is what you do if you want to get tens of thousands of Twitter hits. That's machine learning for you, all the advances. So yes, it's really good because you can kind of get a sense of what you might like to do and have fun with if you ever actually get intimate with a real data set, but it's totally unrealistic mostly. So I'm actually coming from a totally different tact, and I'm sort of channeling a little bit another tweet which got far fewer retweets, which is this guy. He's a sort of an American futurist, and he says, "Strange, I heard a good computer science expert says most firms that thinks they want advanced AI and machine learning really just need linear regression and cleaned up data." And I think there's a lot of truth in that. And so I'm actually going to just give you a totally PG rated sort of data play today, and we're going to pretty much not go beyond tidy data, tidying data, clean data, and linear regression. So that's the basic tools we're going to work with, and also a lot of data visualization and plotting, because I think that's an underrated tool, and we should do lots of that too. So let's get into it. The first fun of a data scientist's life is actually extracting some data, and this is really, really hard to get a good data set and get a hold of it. And so we've got a bar restaurant, and we have this fantastic till system. It's one of the most sophisticated ones. It's based on an iPad, and this is the data that we get out of it. If you ask it to give a kind of, a sort of a 1 month or 2 month backlog, it'll tell you this sort of information. So it's purely just a sort of, a timeline of daily takings. Or perhaps you can get sort of a spreadsheet that sort of does this and sums up everything in that time period. Which again is really, really hard to draw any insights from. They have actually managed to map a little size aesthetic to the percentage of sales in that 2 month period over in a particular hour of the day. So that's probably the second most advanced thing they have, next to a pie chart, of course. Who likes pie charts? Raise your hands if you love pie charts. Oh dear. Okay, so I got on the phone to my dear till system and said, hey guys, do you think that maybe I could access my data? Could you like give me a way of doing that? Give me a file, can I download something? And they said, oh sure, have you been to the tab that says like sales summary? And I'm like, oh dear, I almost had a bit of a Gollum moment where I just said, that's not what I mean, please. I want some real data, actual data. So luckily I had a secret weapon with me, a guy called Ross Ireland, and we just went to the tab that said, tell us about every order. And you can drill down into each one of these methodically, and you get data that looks a little bit like this. And if you're really, really determined and amazingly skilled in R, you create something that queries each one of those systematically and downloads all the data in that format from everything that you've ever sold in the restaurant and builds it back into tidy data again. Which is quite a bit of a thing to do because every order is different. There's different numbers of things there. There's certain specials, there's weekend holidays and public discounts, so the fields change all the time. Quite a few different rules to accommodate and adjust to. But if you can get through that, then you finally get quite an amazing big data set. And I'm always a fan of just plot it first, ask questions later, get it on a page so you can see it, because that's the way that you really understand what the data is. And we do get to that. So that's a bunch of, I think, only 30,000 sales of all the different things in our cafe. So I think it's a huge achievement. I want to give a round of applause to Ross for getting that done. That's a really big bit of data extraction. So you can see here already that it looks kind of realistic because we've got something like just having those gaps in the middle of the days, during the midweek. So late afternoon, we don't see any sort of sales. Also, we know that Sunday we have to close early and open late. So that looks like the data's roughly right. Or we can also look at it just as an overplotted kind of distribution across the full time that we've been open, just about. I think we only got the last one earlier this year. And so that's just this distribution of all the different things that we've been selling across the y-axis. So I think it's just good to get data on the page because you can see so quickly when you plot stuff whether it's really, really wrong and really, really bad. So that's a starting point. But what you really need to do to get any kind of meaningful insight is to get your data into a tidy form. And I want to give credit to Hadley, who's been writing about this and working on it a lot. There's lots of courses you can do on this, which is just about organising data in a really systematic way so that every row contains an observation and every column contains a variable. And I think that once you do that and you start playing with data, you'll realise just how powerful it is to line up your data, not like that, but more like this, because it means that you can go and do some really, really cool stuff in terms of being able to put into various regressions and a whole range of other visualizations. So we're going to have a little look at one of those just now. And I'll just show you our little, I won't do that, I'm going to use the mouse instead, sorry. This is a little app that we were able to build once we'd sort of got our data into a reasonably tidy format. And it just allows us pretty simply to use little filter functions in the background under the code and thin down the data immediately. We can fit a polynomial regression line to it like that. About 9 degrees is good if you've got about 3 years of data. You want to have at least 3 for the first one and 2 for every year after that. We'll just take off the standard error and reduce the opacity of the time series and then start looking at some splits. Let's look at which hour of the day our coffee is growing in the fastest. So this is just looking at coffee data at the moment, but we can see here that 8 a.m. in the morning has actually been growing quite clearly the fastest. Just ignore the last little lips at the end there because the polynomials tend to overfit at the very, very end. Or if we want to find out whether that's the same for other days in the week, we'll quite quickly realise that Saturday and Sunday is very different. We have a different daily spread there. Or if we wanted to add in some other items such as breakfast or some cold drinks there, and we can try to actually split by product category now. And we can see that this is something that I got as an insight from my business which we had no idea about because the business overall was growing, that actually in the morning on the weekends breakfast has been in long-term slow decline. We just weren't able to see that because we couldn't get a regression line to run through the subset of just weekend days, just coffee, all right, which has been driving flat lines in the breakfast as well. Sorry, breakfast decline has been driving a very flat growth trajectory for the coffee as well, which is not so much the case for the other days of the week. So that's an example of the kind of the simplest thing, but the power you get when you're willing to kind of productionize the kind of exploration process, if you like, and build something with a big tidy data set, which is something that we've really had fun doing. So let me just go back to some next little fun exercises. So this is the introduction to a bit of correlation stuff. Who here wants to place a bet? Who thinks that juice is the most closely correlated with the temperature in a bar restaurant like mine? We're open 7 days a week from about 7 in the morning, 6 in the morning to midnight. So we've got a lot of things. Juice, beer, or coffee. Hands up for juice. Strongest correlation with temperature. Anyone? All right, what about beer? Okay. Coffee? Great. Excellent. Oh, that's a good spread. Okay. Well, let's have a look at the data. So again, we managed to get about a year's worth. This is a subset of the data from the Bureau of Meteorology. And I just took an average per hour of the day for every month of the year. And just step that over. You just want to, again, look at the data, see what it looks like weather. Because sometimes you just put something in a format and you just can't quite tell, and you've plotted it something totally wrong, or a different variable's in the wrong place, or it's completely not right. So that looks like weather to me. I was actually really curious to see it mapped a different way to see just how big a gap there is between, I think it's May and June. There's a really massive gap opening up in the weather. I just hadn't noticed that as a Sydney-sider even. But that's the sort of weather we have. It's already been subsetted by finding times when we've also sold data, so that's why there's a gap there when we're closed. So I've already kind of done an inner join which cut out a little bit of data there. But we wanted to be able to figure out what do we do now that we have that weather, how do we get some meaningful correlations out of it. That, as you can see, which is just overlaying the different sale points as points on the page with the temperature, is not particularly useful. So we can thin out the data, which is a good start. So we're now looking at just 7 a.m. to 10 a.m. coffee sales throughout that period of time. But really what we're going to need to do is start thinking about what we want to look out of the data. And the difference I've done here is that I've actually looked at the difference between the temperature and the mean temperature for that month, which gives you a flat line, but still with the same level of noise. So that's a different way of looking at not the correlation with the seasons, but actually the correlation with the relative weather temperature, which is quite a different thing to just looking at the correlation with the absolute temperature. But of course, at some point, what you need to do is start binning to form a time series to actually see how your sales move with a particular bit of temperature here. Now, that's an example of just looking at 8 a.m. on a Tuesday. We hypothesised that because people behave differently in certain days of the week, particularly the weekend, we should look at it on a daily basis. And that doesn't look like a particularly well correlated example, which is a bit of a shame. This is what good correlation looks like. Here I've just mapped the dollar value of the sales of coffee with the number of coffee items that we actually sold at that time. So that's what close correlation stretched out along the same axis actually looks like here, which is quite close. And if you just run a simple linear model, okay, the most basic kind of thing that you can do, this is just a good plain old regression, this is what you get. So in particular, notice that the estimate for the count is 3.44. So that's a really encouraging coefficient because it means the gradient is $3.50 roughly, which is exactly the price of a coffee, roughly on average. Actually, it should be a little bit higher. There could be an error in my code for not adding the extra large size or something to that. It should be a little bit above that, I think, perhaps. But it's overall pretty good for the purposes of our data play that we're doing today. So that's what a good correlation looks like. And of course, you can see there the standard error is very, very small. The t-value is quite large. So there's an awful lot of steps of standard error the distance to get down to 0 from the estimate of the coefficient. And there's almost no chance that occurs totally randomly, which is really, really good. However, if we do a regression on the data that we have for, say, coffee sales versus air temp, we find that we get totally different results, okay? So the estimate of the correlation is 0.04. So we get 0.04 of an extra coffee sold per hour for each degree that the temperature rises, on average, okay? And the fit's quite terrible, okay? So the R-squared value is negative 0.19. So there's negligible correlation there, really a result that we can have almost no confidence in whatsoever. However, and this is the challenge of working with data like this, if we just look a different day of the week, we get a totally different result. Suddenly we get 0.6 for the estimated correlation, half a coffee per degree, and given the fluctuations can be sort of in 5 or 6 degrees between week to week quite commonly, that's actually sort of a few different coffees per hour on average, which is something quite noticeable to the barista. The R-squared is something up around sort of 0.13, so that's 15% of the data is explained by that. So that's quite a different result. So what do you do with this? How do you actually put that data in to make a good model? That's a really hard question to ask, particularly when you just bin it all together, totally aggregate it all up, and you look at all times of the days and just see how temperature correlates with coffee overall. And you get another different result completely. Here you get a negative correlation, okay, in stark contrast to the positive correlation we had before. So again, what can we do here? I think that all you have to do is just look at, again, a good way of visualizing things. And so we built something, Ross built something that was quite good at basically taking those statistical variants and mapping them across an interesting space. So if I just do that, will that get a little bit bigger here? Okay, so That's good. So this is an example of hot drinks, okay? And this is an example of us seeing stuff which we couldn't otherwise see before. So the colour is the degree of correlation. So a strong colour is a strong degree of correlation. The R squared we map to the size of the circle. So a big circle, strong colour, is pretty good. However, the probability of getting the null result from that particular set of data scattered over it is the degree of the shadedness of the squares. So we've sort of shaded over ones that might have fit well because they had such little amount of data. Okay, so the chance of getting the random spattering of 2 or 3 points that seem to correlate well, we shaded out. So immediately you can see here, through the whole week, through the different times of day, where you've got correlation and where you don't. And this shows us basically why, for forecast predicting, weather's not used very much because you have negative and positive correlation at different times of day with the same product. So if you aggregate it or bin it all together, it means nothing. And in most supermarkets, most retailers, they want to forecast the day or the restocking interval, so they never look at this sort of stuff because they aggregate it to a day and they don't get anything useful out of it. But if you explore it visually enough, you can find something really, really good. So the thing that we learned, for example, we had no idea about, we knew that we suffered late on a sort of hot morning, for example, on a weekend because we're closest to the beach. So when it was really, really hot, everyone went to the beach and they didn't come to us. So we kind of knew that. What we had almost no idea about was when it's a hot early morning, okay, we actually have strong positive correlation. Because no one thinks about it being hot in the morning because it's not hot in the morning, but it's relatively quite hot in the morning. And we've never been able to sort of identify that as being a sort of significant driver of how our business worked, that a warm morning would actually improve our sales. So negative and positive correlation, almost perfectly balanced out for the coffee. Should we have a look at cold drinks? Who is cold drinks? Anyone?
Yeah, do it.
Yeah, okay. Negligible, strong correlation. There's a sort of maybe a weak overall correlation. But there's nothing much strong there, nothing much that seems particularly consistent and clear. All right, so who's got their money on beer? Okay, a few. All right. Well, you're half in luck. All right, so this is the interesting thing, is that beer actually is totally not seasonal. Okay, so it doesn't matter if it's the middle of winter and relatively cold compared to the summer, people drink the same amount of beer. However, if it's suddenly a hot day within the summer or the winter, there's really, really strong correlation. Okay, so this sort of exploration is basically just the simple basic steps of us trying to be able to prepare ourselves to do more advanced things. Because once you've got a good sense of where there is a factor, where there's not a factor, you're in a position to start doing some really informed stuff about how you select and train your models if you want to do more advanced stuff. Random forests or even neural nets, but we probably don't want to go that far at the moment. But that's sort of our basic little exercise on correlation. So let's go back to some other challenges. All right, cappuccinos. This is an easy one. Who drinks cappuccinos? One or two. Wow, they must be in decline. Gee, no one else. Who drinks flat whites? Okay, I drink flat whites. Lattes, anyone? Okay, all right. Okay, well that's interesting. So that seems to be basically reflected in the data we have. So we again just used our tidy data. We binned everything and so we grouped it just by individual items here. And you can see here that flat whites have had the strongest growth by far, but they were always actually in the lead. So it does actually turn out that the yellow line in the middle, which is the cappuccinos, they could be in somewhat relative decline. Maybe a little bit, but not in absolute decline completely. So anyway, that answers that one. However, if we look on the weekend, for example, and just use a quick little filter, we can see that maybe the decline is a little bit more substantial on the weekend. So the weekend coffee drinkers are starting to get a little more refined and are away from having chocolate on the top all the time. So anyway. Okay, where next? Vegetarians. Who's the vegetarians in the room? Okay. Do you guys drink at all or much? Or? Yep, okay, interesting, okay, cool. Who thinks that vegetarians would drink more on average than others? Okay. Who thinks that non-vegetarians would drink more on average than others? Okay, interesting, all right. So this is a little bit more of a difficult one, and this is difficult for the normal reasons that you have when you're dealing with real data in the real world, is the data is messy and difficult to handle and get in a proper order. So what I hope to do was just see whether we can just see all the dishes that had veg in the kind of name, and I thought we'd had lots of dishes like that, but it turns out that we didn't actually name things properly very much. We only had like a smoothie or a milkshake and staff meal for Jessup Please Veggie. So we had almost no data on kind of vegetarian dishes that I could find just by name in the evening time when we'd be kind of, you know, actually looking for people to drink at the same time. So it would have been totally cruel to the vegetarians to assume they were drinking less just because we only had dishes that we could record in the morning. So that's the kind of thing which, if you're serious about data, you just got to spend your time working your way around this sort of thing. So we found a different item which actually there'd been a problem with because it was a strange one. It was called a faux boy, which is a pun on the po' boy, which is an American sandwich, and we'd called that something with so many different variants at different points that we didn't have a category variable that we could map it to, so it was cut out of various bits of the data. So we had to do some work to go and find it again, and it was named a whole bunch of different things. So this is where it's named as boys with the option of veggie, and that's mapped over there by sort of who sold it, just to sort of see something else about our data. Here's Veggie hot sauce as the item name, and here's Veggie boy hyphen hot. And I think there's one more, Veggie boy. So we actually managed to find 4 or 5 different places where the vegetarian option of this same thing was recorded, which was really hard to sort of know which one do we use and how do we use it. So we put them all together, which is you know, just a good idea to do. Just mutate a little bit and get new data set or a new visualization. And we can see quite clearly there's a really obvious point here because we actually added this to the dinner menu at a certain point in time. So there's only one of those that really is significant, and happily one of those is always significant. So we've got about 100 data points on vegetarians having a known vegetarian meal in the last year or so. So also more usefully, we can see that there's a chicken faux boy there at the same time also sold. Sold much more popular because not everyone's vegetarian obviously, but that overlaps really nicely. So if we just focus on those 2 dishes, we can remove a whole bunch of confounding variables because they're very similar dishes, sold at a similar time of day, during a very similar time period, when similar staff would have been there. So that sort of thing is the kind of thing which is the boring, mundane stuff that you spend lots of time doing in the real world of data, figuring out what are the kind of confounding variables that we need to control for. So having done that, we then went to see basically what the spread was of all the different products that people who had a bill that had a vegetarian faux boy on it were buying, okay, during that service. And that's the spread we got, which was interesting. So there's another one, which was to look at the chicken one. And of course, what we had to do was to normalize these for the number of people that were actually, the number of orders that we had, because we had so many more orders. So they've been reduced down to the kind of total spend per table on average in each of those categories in a given order. So of course, the obvious thing to do next is to join those things up and see how they go together. Again, use tidy data, bind your rows together, and add something that tells you which grouping they've got, and you see this result. Okay, so who's surprised? This actually says that the vegetarians who are in the blue actually consume considerably more of the beer and the wine and the spirits than the guys that are non-vegetarian. I was surprised, okay? It looked a little bit, I don't know, too consistent and too the same to kind of, you know, make sense. So I wanted to just go check, again, visualize, when in doubt, visualize it. So I just looked at all the different data points and just colored them and spread them over those different categories over a time series just to see. It looks like they are different points. That looks like natural data. I can't see them all sort of overstacked on the same point or something like that. So I can't see an obvious error there. It doesn't mean there isn't one. This is just data play after all. But there is another error. Anyone else spot the error? Another confounding variable back here. The dinner, which is the central column, so it's probably a little bit too small to see. There was actually many more dinners per order, well not many more, but noticeably more dinners per order for those orders that had a vegetarian on them, which kind of makes sense, right? There's fewer vegetarians out there, so it'd be bigger tables where you happen to get one, sometimes, okay? So we control for that too, and go and normalize that and divide that by the relative fraction. So you got, for the same number of dinners, for the same number of orders, you still get vegetarians marginally ahead in their alcohol consumption. So there we are, myth busted, which is fun. Okay. So second last, upselling. I wanted to find a good way of sort of measuring, is it actually significant that certain staff do tend to push other items and actually get an extra sale? Because it's one of those things which you tell everyone to do, but does it really work? You're not really sure. So data science should be good for that kind of thing. Like, you know, is this a thing or is it not a thing? Can we kind of just, you know, rule it out and not bother with it anymore? That'd be fun to see. So again, we had difficulties in the data here because desserts didn't have a subcategory that was consistently mapped to them. So that we we couldn't actually pull out an easy set of desserts, and there's been so many different items in the set that was really, really hard to find. I couldn't recall them as well, which was because my business partner, the chef, likes to make lots of puns and plays on words in all the naming of things, so they've all got really, really strange names. So I couldn't find desserts as kind of my good metric upseller. So I went to tequila instead, because we love tequila and we do sell quite a bit of it. We make a lovely little chaser called Vedita, which is easy to string detect for as well. So we have that in the name of things. So we could find quite quickly that there were upsells to tequila with Vedita, which is this beautiful green stuff with cucumber and coriander and pineapple in it. It's really good. Better than salt and lemon. So we thought we'd just try to see how the upselling went with Vedita. Again, looking at the sales here, we selected a down set. I think this is probably, 40, 50,000 sales in this case. And you can see here by mapping on the staff member, the individual staff member over this, you can see straight away that your data looks real and credible. Okay, there's sort of hot spots for certain staff members. Staff members change, they kind of move in ways. And that's the sort of stuff which I just can't recommend enough. Make sure it looks credible and real as you go along. It looks even more credible and real when you plot it by the day. Again, this is just a jitter. You can see how rosters might have worked here. One person's always on a certain time of the day, or they seem to be a lot more than others. Different days are rostered by different people. So that looks like we got some decent data there to see sort of where the actual sales are occurring, which is a good starting point. I won't go through too much of the details of how we sort of split all the data down, because I've only got a couple of minutes left. But this is how it pans out. Okay, so what we're looking at here is the total sell on dinner orders. Okay, so the total fraction of the sales on a dinner order, that's an order that had a dinner, that each member of staff actually sold. So I've divided by the total number of sales, so that's actually a fraction. So it's quite interesting. One person there, I can't see his name. Oh, it's Thomasine Zedek, not her real name, of course. I wouldn't embarrass my staff like this, but Thomasine Zedek sold about 25% of all the dinner, of all the items on dinner tables for that period of time, which is quite interesting. However, I've included a little print step there, which is a bit of a shame. The sales for tequila were actually quite a lot smoother, and you'll probably see that in this distribution here. So there is significant discrepancy between the sales of tequila on those tables that also had dinner sales as a fraction of tequila sold, and just the sales of dinner. So it turns out that some do actually sell quite a bit more tequila than others relative to the amount of dinners that they're serving. So that seems to indicate that it is a thing. Some people will push or be able to upsell a certain product quite a bit more. Final little thing that I noticed in this exercise, there was a bit of a strange pattern happening with how much money was collected for the tequila relative to how many items of tequila were sold, as you can see there by that blue line. So you got an absolutely dead straight arrow of a line for the dinner orders, but for the tequila we had quite a variance there. So I'm not quite sure whether my staff were giving away cheap shots or they were just recording all the cheap shots that I said they should give as upsells and promotions to close friends and regular and stuff like that. So not sure what to do with that. Again, interpretation is key when dealing with data. Okay. Final little data challenge, okay? And this is just a fun one. In fact, I just want to emphasize really especially here that this is definitely not data science, and no one should ever attempt to do something as stupid as this if you're actually doing it for your job, okay? And there's a simple reason for that. Data cannot tell you more than you can tell face to face. Absolutely don't throw away everything else you know just because you think you've got data, okay? So Tinder dates are super, super, super easy to spot at the bar, okay? One person walks in looking kind of casual, but casual in the kind of way that took them 2 hours to dress for, and they sit on their phone, and they sit really concernedly on their phone and watch it totally intently. And then someone else looking suitably also casual walks in the door, and they jump up as if they've seen a long-lost friend and walk over and say, "Hey, nice to meet you." And that's a Tinder date, and you can spot it from an absolute mile away. And so if you're a serious data science wanting to record the instances of Tinder dates, what you do is you just get your staff to say every time you see a Tinder date, add extra side of mayonnaise to the order, charge them $0 for it, and they'll get recorded in my till, and we'll know every time we have that. So that would be the serious data science way to do it. But even then, there's no way that you could inform a business decision from this, because there's no way of marketing to Tinder daters without spoiling the marketing in the first place, all right? These guys are kind of shy and sort of, conservative, or they don't want to be seen to be going to the Tinder spot with their new Tinder date, right? So this cannot possibly be data science by anyone's good definition. So it's purely for data play, just good fun, right? So what could we possibly use as sort of some kind of labeling, some kind of control on what constitutes a Tinder date? So we have to make this up in this case. We don't have perfect information unless someone wants to correct me. But my impression is that the one key thing is that people are going to meet for a drink and they're going to drink together. Okay, they're going to drink at the same pace because it's not good for one person to be seen to be wanting to get on it too hard. They're going to want to match. Okay, they've got over the first threshold. They're going to have to be able to do it relatively steadily throughout. Okay, so they're not going to rush things, but they are going to drink together. That's probably one of the only things that I can kind of say about how Tinder dates might be seen to work together. The other thing, and the only other control variable to kind of, see whether it fits against is the days of the week they actually do it, okay? So my assumption is, having never been on Tinder, is the best way through your kind of, foreplay texting is not to say, hey, I'm free on Friday at 7 p.m, why don't you take me out to dinner, okay? And so I think people tend to sort of try to edge it in and say, oh, maybe I can slip in a bit after work or on a Sunday arvo, or, you go into the in-between time. So we're looking for a distribution that has consistently ordered drinks together, 2 drinks together, and we're looking to see whether that might be not evenly distributed across the weekdays and things like, Monday to Thursday versus Friday and Saturday nights. So that's the kind of challenge. And I think that we've got a method of going for it. So again, there's you can see here the distribution we managed to figure out, which is the time placed between orders on a given bill. Okay, so the x-axis is the time the bill was opened, and we've just scattered this because, again, scatter plots just give you so much information the eyes can soak up, and you can sort of see how it roughly looks. And you can see how dinners, you've got sort of more of these long streaks, some really, really high rises. Okay, and some of those will be in the same order, and you can see that sort of interval there. There's lots, of course, that are down the bottom with kind of a couple of drinks being ordered at the same time or in the same order, or just a minute later, oh, what did you want? Tapping the shoulder. So that's sort of how it looks. But the really interesting stuff is to see how that looks as a sort of more consistent distribution. And so in this case, I thought a good way of looking at it was a violin plot, just to see sort of what's the distribution. And this is the distribution of the time between rounds. Okay, so this is what's the time difference between the first round you get and the next round you get. And we've already subsetted here to just focus on instances where there were 2 drinks and only 2 drinks ordered on every round, okay? And we defined a round as being if they were ordered within a certain number of seconds. I can't remember what the cut was exactly, okay? So here's our distribution. Now that looks relatively similar across all the days of the week, and you can see this is natural kind of peak at around about sort of 45 minutes where most people are ready for another drink around about the time, but it's a bit of a spread out kind of thing. However, if you look at if there's more than 3 rounds, so we've got 2 intervals, we can actually subset and see now we've got 2 different clear shapes emerging between those that are staying for a third and those that are getting out after just 2 rounds, okay? And again, you can see here, quite interestingly, that there's a shift upwards in terms of how slow the round was if you're one of those guys that are staying a bit longer. So the spikes have got a little bit more kind of, high, but still a little bit plump for those guys that are sticking around for another drink. Again, this is only couples. If we go another step again, actually, most importantly, let's just look at Friday and Saturday. Okay, Friday and Saturday, and the relative difference between this, which is the ones where you didn't stay for 3 rounds, and the ones where you did. Okay, and again, those 2 lines look relatively similar. Okay, they're both kind of long and sort of skinny, relative to, say, this one and this one, where this is long and skinny and nothing particularly going on, and this one has got quite a bulb in it. All right, so again, it looks like we've got a little bit of evidence here of a discrepancy. And again, stretching things a little bit, the discrepancy increases when we go out to 4 rounds. Okay, so this is maybe people going quite well. This is a good-looking Tinder date, probably, we think. And again, that discrepancy can be seen here, where you've got this quite a sharp, pronounced difference relative to a relatively similar long, skinny elongation there. So that's just about as far as we can get, and I wouldn't recommend that at all. Again, purely for the fun of it, purely data play, because that is the silliest question you can possibly ask out of this data set. But I thought it'd be fun just to see sort of how the distribution lay for the fun of it. And I think, oh no, there's one more after that too. But thanks very much, everyone, and yeah, happy to take questions.
So, of those many questions for Aidan, who wants to go first?
Okay, I'm told I don't need a microphone.
Right, okay.
When answering your question about coffee, beer, juice, I factored in iced coffee.
Yes.
Was my model wrong? Secondly, what features of data analysis are you trying to highlight or make more accessible in TrendLock that are more difficult in R or Word or SAS or SPSS or one of the other countless ones that are already out there?
Yep. Okay, good question. The iced coffee, I haven't done the subset of that, but we would sell probably a couple of hundred regular coffees to an iced coffee, so I doubt that you'd have the data to make any sort of serious inference about that. Just not enough of it. The second one, so TrendLock, yeah, I'm not here to sort of pitch specifically TrendLock on its own. I haven't explained particularly well exactly what we do. So we are looking on a kind of project development to try to develop a really good model that would work quite well for this particular sort of business, because this particular sort of business hasn't had many businesses with enough capital to throw, you know, really a lot of analytic power at it. So we're hoping to do that, but also, no, we just work as, I suppose, contractors and consultants. We don't develop a new software. We're not trying to build bigger funnels for anyone and sort of say, here we got the one size fits all. We use R because it's a great language, it's exploding, it's got great analytic power, and we build solutions in that. So we just build our shiny apps and use whatever's available at our fingertips to kind of, you know, build data science solutions. Yep.
One right here in the middle.
Thank you very much. I really enjoyed the presentation. Just a side fan note on the tinder-date analysis. I wonder if you have put in a filter of number of people at the table being two.
Sorry, I don't know.
Like a filter of number of
People at the table.
being
Oh,
two.
it's okay. We have only filtered, because our particular restaurant, the way we're set up, and other restaurants, we're a kind of cross between a bar, cafe, restaurant. And when we were setting it up, for some reason we were kind of cheap and didn't get the full table service package of the till software. So normally at most restaurants you would enter in exactly how many covers you have, which is how many bums on seats you have at a given table. We didn't do that. We just got the cheap kind of takeaway retail-y sort of version and adapted that to our purpose. So, so we've got to extrapolate from other points. So that's what we did do, is we looked at the number of drinks that were being ordered at the same time within a minute or so, right? And we made sure that was 2 and only 2 for all the rounds that were ordered. So that was the method that we used to try to access and infer what the number of people at that table were, because we didn't have the data to be able to put a hard filter on 2 people at the table.
Last one here.
Last question.
Yeah, sort of similar to the question I just want to be very good presentation, but like in terms of the revenue generating, like what sort of advice you can have for the revenue, like increase the revenue or sales or reduce the costs?
For this sort of business, look, the key driver for costs in this sort of business is reducing your staff time. And that's the most important one. If you can figure out whether you need someone an hour later or an hour sooner any day, that's the most important predictor. So that's what we're trying to aim towards, is to be able to actually influence rostering decisions on the time scale of hour or 2 out. I mean, lots of other people in this space are kind of being like, oh, figure out your regulars, send them lots of emails and text them at the right time when they're doing the right thing. I think it's a lot of rubbish. I think that hospitality is a good, down-to-earth, natural business where a good offering is known for what it is. So we're trying to just basically focus on cutting costs. And this presentation hasn't shown you how to do that yet. I completely agree.
Well, can you all please join me in thanking AIDAN? Now it's final closing and announcements time, and hey, I've got the podium again. I should point out that in Prescience courses, we actually teach the use of R to do all that great ggplot2 visualization. In the Introduction to R and Data Visualization course, we do a little bit of Shiny as well, don't we? So if you want to learn how to do interactive dashboards in R and how to do this sort of tidy data and the sort of ggplot2 visualization, which is what you saw, that's in stuff we teach. And indeed, the Advanced R course that's being put together by Fabian, among others, is going to have a heck of a lot more tidy data and a heck of a lot more Shiny. So folks who want to have a chat about the machine learning training or the R training, heck, we even do Python training now, come and talk to me. A number of you wanted to talk to me about a range of things. I should point out that we kind of all, some of us, end up wandering over to the back of the northern building, which is roughly around the Taste. If anybody knows where that is, you know, there's two Commonwealth Bank buildings. We're in one, we're in the south building, the other one's the north building. and we go there for beer. And by the way, our speakers, please come with me. I will buy you beer. You like beer? I like beer. Everyone likes beer. A reminder, folks, prescient trains data scientists, anyone who wants to talk about quantum computing and happens to be a physicist in particular, I want to talk to you. Also, there is a quantum computing meetup that's about to start, and Data Science Sydney and the Quantum Computing Meetup is always looking for new venues. We need a new venue for the new streams. We certainly need a new venue for Ian's new practice and career stream. We may need a new venue for the management and strategy stream as well from time to time. I forgot to also say and thank Justin over there, who's been doing a wonderful job helping us today, that he is also taking care of the management and strategy stream, as those of you who attended would have seen. And at this point, I would like to invite Greg Pearl from N-World to say a few words about the wonderful things he's been doing for the community. Come on over, Greg.
Eugene, thank you, as usual. First of all, I'd like to thank Troy and Kate for videoing tonight. 2 excellent presentations. They should be up on the Data Science Sydney website in about 2 weeks' time. But as Eugene said, there's probably 2 years' worth of Data Science Sydney presentations up there. Please go back and have a look at them. They're all fantastic. From my side, yeah, I purely focus on data science recruitment. Been doing that for quite a long time. I'm working across large corporates, doing a lot of work in the startup space at the moment around artificial intelligence, looking for good data engineers, looking for machine learning, looking for data science consultants, people that are customer facing. That's a bit of the holy grail. If you can find good technical people that can get in front of clients, there's a great need out there for those sorts of individuals. Look for my number, it's on the data science website. Otherwise, come on, go check.
Thank you very much, Greg, and thank you very much, N-World. And those videos will be up, as mentioned, so those of you who want to show the presentation to friends who didn't attend, you certainly can. Is there anyone else who has any announcements or things to say? Of course, come on up, Cash.
Hi everyone, I'm Kashish from If People. I'm a data science and analytics recruiter as well. So I'm working on a couple of roles at the moment. I'm also working on a mix of sort of permanent contract, and some of the roles are also have a January start. So if you're looking for something in the new year, get in touch. You can have a chat with me quickly after this. I'll be here for another 10-15 minutes. Thank you.
Are there any other announcements?